Folks, so for this video, I am going to break down the deep dive a little bit and hopefully give you some starting points so that you feel a little less overwhelmed. Now, one of the things that hopefully you've seen, and if not, if this is new, this will help you in any programming assignment that you do. So before you start coding anything at all, and this is something that was brought up in the lab, right? Before you start coding, you need to plan out what it is that you're going to do. So you need to have a really solid understanding of what it is that the task is asking you. Usually the way that I've approached problems, not just when I was getting my CS degree, but also in industry, is I like to write things down, and I think that that's very helpful. I personally prefer pen and paper because I can draw arrows, I can do sketches and visualizations. I'm a very visual person, so I like being able to write all of those things down. But if you work differently, whatever works for you, right? I know a lot of people like doing whiteboard stuff. Some people like having notes on a Google Doc. For the sake of the video, because I want you to see what it is that I would be writing down, I'm just going to put it into a text editor. But, if I recommend you do it in whatever works for you, right? Again, for me, that is writing stuff down, pen and paper, drawing things, writing notes, sketching things, whatever works for you, right? The goal is to create a guide map or a roadmap for you to be able to follow, right? The worst thing that you can do when you start any problem is look at the problem, open up your IDE, and try to start coding, because if you don't know what to code, you're going to sit there staring at a blank file and you're just going to fall into the void of depression and frustration. If you have a plan for what it is that you're going to do, if you have a rough idea, a rough guideline, outline, whatever that may be, you'll, open up your IDE, look at your notes, say, okay, I know some snippets of code to write, right? And just having that confidence of I'm able to write a couple lines of code and get started, that is really, really big. It'll release the happy chemicals in our brain that we need to be able to keep going. So again, this is super important, not just for this deep dive or this class, but more broadly, any future programming assignment that you do in any course. Making sure that you plan everything out is super, super important. If you have a printer at home or access to a printer, and you can print this assignment out and write notes directly on it, highlight things, that can also be super helpful. Not environmentally friendly, but it is something that I have also found helpful. Like I said, so that you can see everything that I'm writing down, and to save some trees, we're going to be doing everything on an IDE, all the notes that I'm going to be doing. So when you get an assignment, especially something that's this long, right? It's really long. There's a lot of information. The first thing you need to do is read through it once. So I'm not going to go through and read this because you can all read this on your own, and hopefully you've read it once over. But just going through, reading it once over all the way without stopping, just so that the back of your brain, you can, subconsciously your brain is going to be doing a lot of work. So if you read this one time over, whatever day it is that it comes out, read it once over, maybe put it to the side, go do something else, and then come back and look at it a little later and actually break it down and take notes. You'll notice that you'll get a better understanding of the second time. You'll get a better understanding of what it is that you're reading the second time around. Another great thing to do is if you're reading it through the first time through, right? So you're reading it through and you start saying, right? So for example, I don't think I remember covering files, or I don't remember how to do files, or I never learned how to do files. I now understand, or I see that based on this assignment, based on one of the things that we're going to be doing, I'm going to have to be working with files. So I'll read this assignment and then I'll go look for how to do files, right? What that entails, right? So can easily Google it up, C++ files. I've brought this up before in our prep work. There is this textbook starting out with C++. Huge recommend. I'm not going to click it now because it takes forever to load because it's a really long file, but it is really great. I actually think I have it saved here. So let me pull it up so you can see, if you haven't opened it, so you can get an idea of what the book looks like. It's again, a really long PDF, so I recommend you download it instead of trying to load it offline or online every single time. And the other nice thing is it's an actual book, and the chapters have bookmarks. So files, I believe, are chapter 7. Where are files? So this book is interesting because it doesn't have files as a unit on its own. It introduces them at different points. So for example, when it introduces the concept of loops, that's the second time you see files in this book. The other time you see files is super early on. Here you go, chapter 3, Introduction to Files. As if you've never worked with files before, definitely recommend download this book, do the quick reading. So it takes you down to Introduction to Files. It tells you, these are the basic steps for working with a file. It teaches you about different types of streams, right? There's streams for just reading, streams for just writing, and streams for reading and writing. Tells you how to open the file. Talks about using the file, writing information to a file. So it's a really in-depth and really readable. I like this book because it's really, really readable. So it goes through, gives you code examples. Again, when you're looking at code examples, don't just skim them through. Actually look at what they're doing. Copy the code. Well, it's a little hard to copy because there's the numbers there, but write over the code on your IDE, copy it down, run it, see what it's doing, see what happens when you change certain things, right? Learn from trial and error. Then close files. So that is the unit on 3. So again, that's in chapter 3. And then if you go back up to the table of contents, you'll see that there's another section on chapter 4. Where are you? So testing for files, this is important as well. That's chapter 4:14. So again, it's in chapter 3, 4, and 5. So testing for file open errors, this is, if a file doesn't exist, what happens? What should you do? How do you handle that? So that is 4:14. And then chapter 5, where it talks about looping. So 5:9, chapter 5, section 9, goes over using a loop to read data from a file. So again, this resource is available. It is on the website. Recommend you download it. Again, that is starting out with C++. And the other really great resource are these. So, let's say you read about files, you're not feeling super comfortable with it yet, you want to get some more practice. So you can go to this document. CSU 200 is very, very similar actually topic-wise to 211. So if you didn't take 211, or if you're not confident about the material you learned in 211, you can access this material that's based entirely off of the book that I just showed you. You can look at the slides that I have. They're linked in various units for the topics that I gave, and the in-class practice problems that I did, the notes that I gave in class, and you can do these practice problems. And if you have any questions about these, you're more than welcome to ask me. But again, we go over all of the stuff that is gone over in 211. So if you want to, take 211 again on your own, or just review any of these topics, this is super helpful. If you don't see this menu when you first load it, you can click on View and then click on Show Document Outline. You'll get this little icon. You can click on it, and see what units these are, right? So we've got everything from what is programming, learning if statements, loops, functions, arrays and vectors, classes and objects, again, classes and objects, files. So let's say we're looking at files. So if you're going to be reading the book, which I definitely recommend, I actually write essential questions from each chapter. So I tell you which sections to read. or I told my students what sections to read, and I gave essential questions. And these essential questions are great for taking notes. They're great for guiding your reading, right? Because it's so easy to, if you're reading something, your mind starts to wander, you kind of lose track of what you're reading. If you're not taking notes, you're done reading a page and then you realize you don't even know what you read. So if you copy these down, copy them over into a Word document, a Google document, a text document, write them down on your journal, your notebook, whatever you want, and write the answers for them. And that way you can also create a document for yourself that's an easy reference for later, right? If you do essentially a cheat sheet for yourself, that can be super useful. And then here's, for example, the practice or the lab that I gave my students. So you can go ahead and play around with that and see, do I have a good understanding of files, right? Can I get this practice problem done? So that is the spiel for, you read it through an assignment and you realize, shoot, I feel that I don't have the prerequisite knowledge for this, or I want to review it. You can go ahead and I've shown you 2 resources, the book and these essential questions and lab practice problems. And of course, there are tons more resources here. There is the material from 211 from fall 2019. There's a whole online course, a Coursera course if you want to take that. There's some tutorials. So for example, some of the links that I give. So Khan also has a programming unit. It's not in C++, but there are 4 resources. I'm going to be adding some more resources. I'll send out an announcement when those are ready. But I've gotten some more resources from Mike Conti, 211 instructor, on resources that could be helpful for y'all, specifically with C++. But down here, there's a bunch of other sites. I love W3 Schools. So I teach the web dev courses here, and W3 Schools is the go-to for myself and all of my students. And they actually have a surprising amount of tutorials on everything that I have ever searched. There's a W3 Schools page for it. So definitely recommend you check those out. Tutorials Point also has really good tutorials. Personally, I like W3 Schools more because they are easier to, there's always a try it out and you can go ahead and play with the code and try it and see what's happening instantaneously. With Tutorial Point, they're good tutorials. There's a lot more reading though, and you can play around with the code. So if you're someone who learns by reading instead of doing, probably Tutorials Point might be better for you. If you're someone who, like me, learns by doing, and I think computer science honestly is something that you can really only learn by doing, then doing W3 Schools, doing a combination of the two. The C reference site is actually one that you've already seen because this is the site that I gave you all for that Wetto. They have tons of tutorials, articles. There's the reference, so whenever you want to look up a specific function or type or whatever it may be, they'll have that, but they also have really great tutorials. And then we have a couple of cheat sheets as well. So if you forgot how to do something, if you don't know the syntax for something, you can go ahead and pull that up. Another thing that I'm working on, FYI, is creating a cheat sheet of this is what it looks in Python, this is what it looks like in Java, this is what it looks like in C++. I know a lot of you, those of you who've taken 110 definitely have that Python experience. Those of you coming in with either AP credit or from CCRI, you have that Java experience. Between if you went to CCRI and did the C# version of the classes, the syntax is so much closer to C++ that there's really no point in doing an equivalency chart. But like I said, it's a work in progress. It's going to be posted. I'll send an announcement out when it's ready. Like I said, it'll show, this is how you declare an if statement in Python, Java, and C++. And that way you have a super quick reference or cheat sheet that you can see for, the differences in the language that you probably know. Okay, so a lot of talking. We're not even at the deep dive yet. Okay, so let's go to the deep dive. All right. So now that you know where to find these resources, right? So presumably you read through the entire deep dive once through, you looked up through the prep work and all these resources, whatever it is that you didn't know or weren't familiar with are, and you're feeling confident. You're like, okay, I understand files, I understand command line arguments. because I did the practice problems that had them, I revisited them, or, you know, I learned them on my own. I went to hours, I posted on Piazza, I scheduled time to meet with Victoria, and I'm feeling good about the prerequisite material needed. I think I can take this deep dive on. So what you should be doing right after you've done all of that, and again, you haven't even touched code at this point, right? This is why I say start the assignments early. All of these assignments, the programming, there's not a lot of programming involved, but there is a lot of planning involved, especially with preparing with all of the knowledge, all of the background knowledge, and especially if you know you have certain weak spots, or if there were things that didn't get covered, or whatever it may be. That is going to be the bulk of the work that you're going to be doing. So the sooner you read this, the whatever assignment it is that's currently out, and the sooner you get all of that prerequisite knowledge, the better off, the sooner you'll be able to start this. So, okay. Spiel, done. I read it everything the first time. I understand what image renderization is. So I want to go down to the requirements, right? Because I want to really understand. Actually, you know what? I want to go to your task. I want to really understand what it is that I'm being asked to do. So I understand that I'm going to develop a command line tool, right? And what that means is I'm going to write something in C++ that when I compile it, it's going to create an executable, and that executable, when people run it with whatever the arguments are, it's going to do the thing it's supposed to do. So I want to jot these down, right? Because I mean, this is a hefty assignment in terms of wording, right? There's a lot of text on here. So I want to write all of these things down somewhere where I'll be able to more easily access it. So what I'm going to do is I'm going to have some notes. Excuse me. So down here, back to the task, I'm going to write this down. It's going to look funky right now because of sizing. And I apologize. I know the videos end up getting a little longer because I have OCD and need to make sure things are properly formatted. But hopefully it also helps you see where things are going. Okay, so again, this is with the assumption that I've already read the assignment, I've already done the prep work, and so I know what it is that I'm being asked to do. I just want to figure out where to start. So I know that I'm doing an image registration, I know that I'm doing a command line program, so reminders to myself. So global thresholding, I know what that is because I've done the background reading. I'm going to use the median for all of the pixels for value of t. Okay, and I know my formula. Again, reading all of this over, copying it down, making sure I understand it. If there's anything that I don't understand, for example, standard deviation. What's that? I don't know. Standard deviation, look it up. So how do you calculate standard deviation? This looks like a formula that I need to write down. So, oh look, there's steps right here. That is amazing. Instead of writing down this formula, that is probably not going to be super helpful, right? For some of you, it might be, right? If you're comfortable with math and you want to write down the formula and you can calculate or write your code afterwards, awesome. But the really, really nice thing about this is this can easily translate to pseudocode. So looking up these terms or formulas that you don't understand or that you don't know or that you haven't seen, it's gonna be super helpful. So I'm gonna take notes of this. And you know, presumably I would have read this, I know what standard deviation is, but presumably you would read this, understand what standard deviation is, understand how to calculate it, and then make a note here for yourself, right? So S is the standard deviation of the local neighborhood center at pixel ij. Okay, so I'm going to make another note to calculate. Okay. So if you look at this, like these steps that are, I cannot emphasize this enough, these steps that are written out, all you have to do is convert that to pseudocode. And once you convert it to pseudocode, you'll know exactly what code you need to write. So this is so incredibly helpful. So, okay, we've defined standard deviation. Everything else in this formula. So the mean The mean is the average. Hopefully you know how to calculate the average. If not, again, you can look it up. Calculate mean. The mean is the average of numbers. It's easy to calculate. Add up all the numbers and divide by how many numbers there are. Okay, in other words, it is the sum divided by the count. So mean, to calculate the mean. So this is step 1. Add up all the numbers. Oop. Then divide the sum of all added numbers by how many numbers there are. So cool, we have some steps here for how to do this. So we know how to calculate the mean, we know how to calculate the standard deviation. This is a constant number, so I'll just make a variable k and set it to 2.2, same with r. Pmax is the maximum pixel value in the entire image. So I'll make a note for myself, right? So I need to, as I'm parsing, or as I'm reading in the pixel values, I need to, oh my goodness, I can't type, need to check for the highest pixel value and store it in Pmax. You need to do the same thing for the minimum, so you can just copy that note over for yourself. I need to check for the smallest pixel value and store it in Pmin. So again, we have concrete steps of what it is that we need to do, right? So honestly, like, I'm feeling super good about this. I know how to calculate the mean. I know how to calculate the standard deviation. I'm telling myself, okay, I'm going to open up that file. Again, I've done the prep work, so I know how to open up a file and I know how to read it. And I know that these numbers that I'm going to be reading, I am going to have to keep track of the maximum and the minimum so that I can use them later on in the formula. So we've got a good amount of notes here. All right, let's see what else we have to do. So then it's just really the command options, which honestly, I can worry about this later. I want to focus on making sure that I understand this algorithm, that I understand the directions and what it is that I need to write. I understand how these files are coming in, right? There's numbers separated by a space, and the numbers can be between 0 and 255. And notice that we are not expecting for you to do any error checking, right? So it's not like we're asking you to check that it's a valid file. You can assume that we're going to give you a valid file. So that's something that you don't have to worry about, right? So no need to check if the number is less than 0 or greater than 255. You can assume we're just going to give you a good old .img file that's properly formatted. So that is something, you know, in the real world, if you were doing this for a job, they would ask you to be doing all this error checking, right? Because what happens when you get noisy data? What happens when you get improper files? What happens when you get things that you shouldn't get, right? When it's not even the file that you were expecting to get. You don't want your program to crash. But for the second purposes of this lab, we're not even asking you to do that. So then we'll look at the requirements again, right? So at the end of, like, as I'm looking at this, the two biggest things that I really need to worry about right now are calculating the median. Oh, that's the other thing, you know, calculating the median. So I'll get to that in a second. So doing global thresholding, which I do by calculating the median of all the pixels for the value of t, and then being able to implement this formula. So other notes for myself, right? I need to make sure to use the double. So I'm gonna put that in caps lock here. So use double for everything. And that way I don't forget and accidentally end up with weird round off errors. Main file, how to compile, output, functions and classes. Oof, not feeling good about that. I will worry about that later. I want to make sure first that I can get my code to work, right? And if you looked at the wet tail video, which I recommend you do, you'll see how you can go from having this well, it wasn't a massive main function, but having everything in your main function, how you can figure out how to abstract it out, right? Like what does a task? And you can do that later. But for the purposes of this right now, right? If you're feeling stressed and you just want to get started and you want to get that functionality, focus on this. Don't worry about the functions and classes. So again, we see the median of all pixels. Okay, so how do you calculate the median? How to calculate median. So again, bless Google. Not a fan of their ethical principles sometimes. Use your search engine of preference. So we see here, this is how we calculate the median. So I read it, make sure I understand it. Cool, got it. Gonna make a note for myself here. To calculate the median. And again, having those numbers of steps is super helpful. 2, 3, 4. Okay. So we have an odd number divided by 2 and round up to get to the position of the median number. So this is important here, right? And hopefully with the essential, we didn't get to doing the mini lecture on the math overview, but you should be reviewing the slides. So round up. So this should trigger a bell in your head that says round up. I remember seeing this in the lecture slides, right? So round up is you take the floor of, or no, sorry, the ceiling of something. You're rounding up, you go ceiling. If you're rounding down, you go floor. So if you see this, right, this should trigger a bell and say, okay, well, I know that if I'm rounding up, I need to calculate the ceiling of something. So ceiling, how do I do this? Okay, so it's literally a function called ceil. So I'm going to make a note for myself here and say use ceil function. And in case when I'm looking back at this, I don't remember what that means, I'm going to paste the link that I found. You have an even number divided by 2, go to the number in that position and average it with the number in the next higher position to get the median. Oh, that looks like an extra step. So you know what I'm going to do? Gonna do this and call it like 4A. Because I know that when I'm coding this, this set of instructions, this step, is actually going to be some code that's nested inside this if. So I want to make sure that I have that super clear in my notes. Okay, let's see, what else can I write down that'll be helpful? Yeah, I think in terms of like what the actual instructions themselves are, I'm feeling good. So the other thing I want to do is, I remember that when I read this through the first time around, there was some pseudocode. I kind of ignored it, but I probably want to go back and look at it again. So the algorithm here shows how to binarize an image. Okay, so look at this pseudocode. So I get an input of a grayscale image, I output a black and white image. The code says calculate the global t. Okay, so this is for global binarization. This is the pseudocode that I need to do for this global binarization part, or this global thresholding part, excuse me. So if you're using something like a Word document, it'll be easier to organize yourself a little bit. I'm just going to put in a lot of spaces here. So this is for everything. This is global thresholding notes. This will be local thresholding notes. And that way I can keep my things separate. So I have the pseudocode here. So calculate the global t, which you do this way. For each pixel in aij, so aij, well, you know, what is that? It's important to note that the pixel values for an image are stored in a matrix. Okay, so this This is probably going to be true for both my global thresholding and my local thresholding, right? Because when I'm reading in those pixel values for the image, I know I'm going to have to do some math regardless. So I should just probably read it in and store it into a matrix. Though we do tell you at the bottom, if you want to use an array for a regular one-dimensional array, you can. I recommend you use a matrix just because that way you can follow along with the pseudocode. So when reading in file, store pixel values in matrix. Now I'm thinking, well, I have this thing that I'm going to be reading. It's a string, right? Because it's text that's coming from a file. And if I'm going to be doing math, I probably want to convert it somehow. So before I forget, let me Google this. So convert from string to, and that note right there tells me to use a double for everything. So double CPP. So it's easier to search CPP than C++, just because everything is abbreviated as CPP. So you'll see that clearly I do lots of Googling on C++ stuff and do lots of references searching. So stod, our favorite website, c++.com. So what does stod do? It converts a string to double, parses stir, interpreting its context as a floating point number, which is returned as a value of type double. Shoot, that sounds like exactly what I need to do. So you know what? I'm going to make a note here to store as double using stod function to convert. And again, just in case I forget or don't remember how to use it, I'm going to give myself that link there so I can look at that later. Okay, so I'm using a double for everything. I'm reading in the file. I'm storing the pixel values in a matrix. Let's see what else this says. Matrices don't have to be perfect squares, blah, blah. Your program should work on images of any dimensions, perfect squares or not. Okay, cool, got it. So this pixel, this AIG matrix is going to be this matrix. So I'm going to say, call it A, right? Because that way when I copy the pseudocode, I can remember that that's what A is called. So for every pixel A in A, do if the pixel value is less than T, which is the threshold, then make it 0. So this B looks like a new matrix. So I need to make a new matrix, which is going to be my output matrix. So create output matrix, call it B. And that's not saying like this is what it has to be called in your code. It's just so that when you look at your notes later, you know what's associated with what. Be descriptive in your code, please. So this variable, as you're making it, don't call it B, call it like output matrix and input matrix and things like that so that you know what you're looking at. This is just for the sake of the notes that I'm taking. Else, turn it into the 255 value, and if, and for. Okay, so I understand what this is asking me to do. I understand what the pseudocode is saying. So now what I'm going to do is I'm going to copy the pseudocode into my notes. I'm going to say see above for how to do this, right? Because down here, or up here, I have how to calculate that T value. Cool, so I'm going to go down now, local thresholding. So again, presumably I've read this. And I know that the neighborhood of pixel B is a small matrix of dimensions DD, D times D, or D by D, centered at P. In this case, for each pixel in the image, we're basically calculating a different T. Okay, got it. So I'm going to go down to my local thresholding notes. I'm going to add some more enter spaces down here so y'all can see everything. All right, so same thing. We have that A, and in this case, we have this T. So that's going to be a separate matrix for this, right? So I have these notes here that are general notes. So let me general notes again so that I remember This applies to everything that I'm doing. This applies only to global thresholding, and then everything down here applies to local thresholding. So it looks like I'm going to need to create this new matrix that's separate, right? I have my A and I have my B. My A is my input, my B is my output. So I have to do that Tij. Now Tij is the threshold for that neighborhood, right? So remember, we're using T for threshold. Threshold, that's a hard word to say. So okay, so for each pixel Aij and A, do calculate the threshold of that pixel, right? So with local thresholding, you're calculating a threshold for each individual pixel by using the local neighborhood. That is super, super important. With local thresholding, you're calculating the threshold for each individual pixel using the local neighborhood. Okay, that local thresholding is pretty difficult. Global thresholding, it's, if once you have all of these notes yourself, go ahead and start implementing it. This one can be a little bit of a doozy, right? There's extra steps in there and some extra math where, like, if your parentheses are off, it's going to throw everything off. So this one's a little bit of a doozy. So, okay, I'm calculating the threshold of that. So I need to have that variable defined, right? So I'm going to make a note for myself. So for local thresholding, I'm calculating the T for each pixel. Ooh, not piel, pixel. Using local neighborhood. Local neighborhood, is matrix of dimensions, size, whatever clicks in your head, D by D, centered, centered at the pixel. Okay, so it looks like I need a specific matrix of these dimensions. Okay, so I need to keep that in my mind. So I calculate the threshold using the local neighborhood. Okay, and we have the formula for that here. No, we have the formula here and what that means here. And then it's very similar to what we did before, right? So if the value of that pixel is less than the threshold, then we're going to make that 0. Otherwise, we're going to make it 255. And that's it. So I don't mean to say, and that's it. Like, it's not a lot, because it is a lot to process. But, we're looking at the pseudocode. We understand the pseudocode. We go line by line. Cool. We get it. Like, I can move on from this piece. So, okay. So I have here my general notes. I have my formula. So I'm going to put the pseudocode down here. Oh, did not mean to do that. Okay. So local neighborhood. So similar to how I wrote the note at the top, I'm going to say use formula above to calculate, remember local neighborhood. Remember what local neighborhood means. And this is so that later when I'm coming back to this, I'm like, well, what is the local neighborhood? And I can go up to my notes and read this. And if I go through, right, like that is all of what this is telling me to do, right? All of the other background information, again, I've already read it, I've processed it. I'm looking for what it is that I'm supposed to do, right? And I'm not even worrying about the command line arguments for now, because what the goal of this is to get you a place to start. So we have all of these notes. We have this pseudocode. I'm feeling pretty good about this. I feel like I can go ahead and start coding. And like I said, I don't want to start the code for you. I want you to go through this process yourself. It's going to look different for you, right? Like if you know what standard deviation is, if you know what the mean is, if you know ceiling and floor and how to calculate all of this, you may not have to look all of these things up. But if you don't, whenever you don't know how to do something, look it up so that when you're coding, you don't have to stop, right? Because when you're coding, you get into a groove. And if you break that groove because you're like, oh crap, I don't know how to do this, it's going to be hard coming back. But if you take the time to plan this out and you take the time to look up things that you don't know ahead of time, you can put all of this into your notes. And that way, when you're coding, you look back to your notes and you say, oh yeah, I was going to use STOD or STOD. Cool. Let me pull up this link so that I know what parameters it calls or what it returns or whatever that may be. So hopefully from here, right, you know where to start, right? I remember to use a double for everything. Again, I've done the pre-work or the prep work, on files. So I'm feeling good about files. I know how to open a file, how to close a file, how to read a file, open, read, close. And I can start doing this, right? Like I know that as I'm reading in, I'm going to store the pixel values in a matrix. And then I need to have an output matrix called B. And then I'm going to implement this. I'm going to take this and translate it. So I have the pseudocode here already. So something that's really helpful when you're doing the pseudocode, or writing the actual code is, so you have this giant thing of notes, right? When you start coding, copy this in, right? So copy this in, leave it as a comment. Depending on the text editor you use, there's probably a shortcut to take a chunk of text and make it into a comment. So let's say that these are my, dd1notes.txt. And then let's say I create a new file, and this is going to be my CPP. Oh, can't. I have another main in there. Main dd. And I have my int main. So depending on your editor, it might do some autocomplete for you, and you're starting. And again, when you're starting off, don't worry about classes and functions, right? Like if what you want to do is you want to get that functionality down, you want to make sure you understand the problem. So, I'm going to copy this in just to show you like the process. Again, I'm not going to actually write code because I want you to be able to do that. So for me, if I do this, it automatically turns everything I highlighted into a comment. And that way, I'll start with, okay, so let me first, open the file. And then I'm going to read the file. Wow, I combined what I said with what I typed. And then this is where that comment's going to come in. And then this comment's going to come in. And then I'm going to write my line of code right here. I'll do my line of code, line of code, line of code, and so on and so forth. Don't know how long this video was. I apologize if it's lengthier than, well, I apologize. It does feel lengthy. My throat hurts from talking. But hopefully it's helpful. I hope that this is a one and done thing, that, by knowing and seeing the process that I would, for example, go through to prepare and plan for this and take down notes and do the pseudocode, hopefully you can take this and start doing that moving forward with any programming assignment, right? Whether it's a wet toe, whether it's a deep dive, whether it's a lab assignment, doing that prep work, doing that planning, really understanding what it is that's being asked of you is super, super important. And from here, I mean, you have the pseudocode here, you have the formula here, you have the pseudocode for the formula, you just have it in English sentences. All you have to do is essentially go line by line and convert that into C++ code. So doing this is going to save you so much time in coding. And the other nice thing of having this is that if you get stuck or you're having a mistake, or you don't, something is wrong and it's not working, you can always refer back to your notes and you'll see, okay, I said I was going to do A and B and then C. Is that what I'm doing in my code? Chances are you forgot a step, you reverse the step, you swap the order of the steps. So having this as a guide, as a plan, is going to help you. It's going to help you code much faster. It's going to help you debug much more easily. It's going to help you really understand what it is that the problem is. So, do this for everything that you do. It'll save you so much time and so much effort. I've been programming for quite a while, and the only gray hair that I've gotten has been from teaching. So this, this, doing this saves you. It de-ages you, because it makes the experience so much. It just goes so much more smoothly and so much less stressful. So, like I said, hopefully you found this helpful. If you have any questions, post on Piazza, and best of luck getting this done. I believe in you. You're all going to do great. I know it was a stressful first week, but I have full confidence in all of your abilities. You're all super driven and super passionate. You've been asking questions because you care. And yeah, it's not, I remember in the chat, someone said, we're engaged because we're lost, but you care. You care enough to be engaged despite feeling lost. You care enough to be advocating for yourselves and asking for these resources and, demanding that we as a department do better. And that's an amazing thing. So keep it up, put in the work. I know it's not easy. It's part of the learning process. And I'm hoping that from here on out, it goes a lot more smoothly.